So we're going to look now at the same procedure, but dealing with the pre-1982 pennies. So these are pennies from 1981 and before. This is the bottom data table on the lab. So it's the same steps that we did for the post-1982 pennies. First thing I want to do is I have a graduated cylinder filled with 40 milliliters of water. So I'm not using the same because I want to go back and show you the volume displacement with both of them. This is the one that we just did, the post 1982, but this is the same make, so we're going to say that it's very similar in terms of sig figs. The masses might be slightly different, but the sig figs is so minor that it's not going to be an issue. I want to make sure that I tear my digital scale. So this is now the mass of my graduated cylinder plus 40 milliliters of water, and I have the bottom of the meniscus right at 40 milliliters. So the mass of this is 109.51. 109.51 grams. I know that it just jumped up to 0.52, but it keeps going back and forth. So we're going to say 109.51 grams. And we can talk about that later if there's a discrepancy in terms of the mass of the volume in water. Sorry, the volume of 40 milliliters plus a graduated cylinder between the post and the pre. We can discuss that later. So this is my initial mass, but what I really want for my data table is I want the mass of the pennies plus the graduated cylinder filled with the water. So these are the pennies from 1981 and before. Some go as far back as the 1940s. That was about 6 of them. This is the remaining 6. So I took a total of 12 pennies for post, 12 pennies for pre. So now the mass of everyone, the water, the pennies, the graduated cylinder, we're going to say is 146 point, we're going to stick with 49, 146.49 grams. Okay, so now what I want to do is I want to walk you through the volume. So I'm going to bring this up a little bit closer so that hopefully you can have a better view of it. And to help you see it, I'm just going to hold this part up. So remember, this is where you want to do your reading of it. So the 45 mark is right there in blue. And so what you want to figure out is you want to figure out where does the volume end. Well, if 40 is right here and 45 is right there, what that means is that each individual line is a total of 1, because to go from 40 to 45, you only have those markings. This is 41 milliliters, 42 milliliters, 43 milliliters, 44, 45 milliliters. So the pre, I would say, is not touching the 44 milliliters because that line is right there. The 45 is right here. I would say that the pre-pennies, that's 41, 2, 3, 4. I would say that's 44.6 or even 0.7 milliliters because it's not even halfway. The meniscus is, okay, let's just make life easier. Let's just say this is 44.5 milliliters because the meniscus is, we're going to say it's good enough where it's right between the 44 and the 45 mark. So the pre-pennies, the displacement, the water rose all the way up. It went from 40 milliliters to 44.5 milliliters. If I now look at the post displacement, so the pennies from the post, and I bring those back over, let's go through that process together. So I'm going to show you where the numbers are. There's the 45 mark. And then again, this is the 40. So what happens is those two larger lines, those two longer lines, that's my 40, that's my 45. Each line is an increment of 1 milliliter. So to go from 40, 41, 42, 43, 44, 45. If you look at the bottom of the meniscus, I would say that that's 44 milliliters. So you want to make sure that you're calculating the displacement. You're looking at your volume, the final volume, the after, minus the initial volume, which for both cases was 40 milliliters. So going back to your data table, the post 1982 pennies, so pennies from 1982 and after, they started at 40 milliliters and they ended at 44 milliliters. So now you can figure out the density of the volume of those 12 pennies. If you go and look at the pennies from 1981 and before, their water level went all the way from 40 milliliters to 44.5 milliliters.